factors that can take away a lot of our capacity to deal with new threats. Then what happens, new threat comes, we don't have capacity to deal with it, and now we get sick from it. And this is how we then develop the flu. It's not that much different with the coronavirus. With the coronavirus also, you will get sick with that if you don't have the capacity to deal with that. The less capacity you have to deal with it, the sicker you will get. If you have no capacity to deal with that, it can actually even be lethal, unfortunately. So this is where we can do something to prevent catching it. We can postpone it. But it's not very likely that we will be able to never get exposed to it. The National Institute of People's Health in Norway, Folkehelseinstituttet, they recently now published that they expect 70% or up to 70% of the population in Norway to get this. So if we escape it now and we just go around and we're very worried about it and we stay at home and we can delay catching it, and then maybe we can get sick with it a year from now instead of next month. But does it really matter so much? Because you actually build immunity once you have it. So maybe it's a good idea to just make sure that you can handle it, that when the exposure comes, you have the immune system to deal with that, you have the capacity to deal with that, and so that you're just going through something that is a bit more light. Like the flu. Who's worried about the flu? Some people actually die from the flu too. Every flu epidemic, some people die. But we're not that worried about the flu because we have had it before. We know that we'll be okay. We feel horrible when we have it, and then we'll be fine again. That is how it is for most people also with the COVID-19. You will feel not that great when you have it, and then your body will fight it, and then that was it. The statistics show that it's between 0.3% and 0.9% that can die from this. 0.3 to 0.9. That is much higher than with the flu. But yet, it is also more contagious because the coronavirus, this particular virus that gives the COVID-19, it has 4 extra what's called spike glycoproteins onto what is exactly the same as the SARS virus. Before I go more into that, maybe I should tell a little bit what a virus actually is. So a virus is not a living microorganism. It's not like a bug that is alive itself. It is a DNA or RNA-based program, basically. It's not alive, but this program goes into the cells and it makes the cells produce more of it. So that's how it reproduces. It's not procreation. They're not, mating and making baby viruses. They make your cells produce more of the same virus. So the better your cells are able to not choose to follow that program, the better you will also stand a chance of not just reproducing this again and again and again, which is also where you need the capacity and you need a good cellular health so that your cells are strong enough to not overproduce a lot of this virus from that program. What also the virus does, any virus, is that it will also make the cells behave differently in some way. So it makes the cells reproduce it, and it makes the cells behave differently, such as reducing the activity or changing the activity to something else. And then you have the third type of reaction from a virus, is that when the immune system is fighting it, then you have reactions from that, such as the fever. But that's a good mechanism. That is what we actually need to fight it. So, so those mechanisms that are just a consequence of the body's fight against it, those we should be very happy about. You should feel thrilled and blessed when you feel those symptoms, because it means that your body is fighting it in the most beautiful way. So these viruses that are just these programs, then they will not be able easily to reproduce inside your cells if your cells are strong, if they can function in an optimal way, if you have the optimal capacity to regulate, if your immune system can fight what you've been exposed to. So this is a very, very important factor. So let me go a little bit back to the specificity, the specific aspects of this coronavirus. So as I said, you had 4 extra spike glycoproteins onto the SARS virus. And that can happen in nature, that a virus develops, it mutates, it can even mutate in one person, because it depends on what cells it goes into, and maybe those cells have some other challenges. Instead of reproducing what the virus wanted, which was an identical copy, the cells might reproduce something similar, which is not exactly the same. And then you have a situation where you have a certain type of mutation. And this is one of the reasons why a flu is difficult, because there are all the time mutations creating new flus. That's also why it's difficult, well, one of many reasons why fighting a flu epidemic with vaccines is very difficult. Many years, those strains that are in the vaccine are completely missing those strains that people are actually exposed to. So now, these 4 extra spike glycoproteins, they all come from the same virus. So now, if you know a little bit about statistics, to have one of these match another virus, that can happen by coincidence. But to have 4 of them, which all match the same virus, that cannot happen by coincidence. It is actually more likely to win the big lottery 4 times in a row than for a virus to develop this way. Which is why this is an engineered virus. This has not been developed through a natural evolving process. And it is even published. The first publication about this that came to people's awareness, it's actually not the first publication, but the first that was really coming to people's awareness, was a publication done by a renowned institute in India, where they measured these 4 additional spike glycoproteins, and they all come from HIV. So it's a SARS virus with 4 extra spike glycoproteins from HIV put together to like a superbug. What we can be very lucky about is that these extra 4 spike glycoproteins have not engineered this to make it more deadly. On the contrary, it's just engineered to make it more contagious. So, like with the original SARS virus, it wouldn't be contagious as far distance as this one is. So this virus is highly, highly contagious, much more than other viruses, because of the way that it is engineered. It's actually consciously engineered to make it more contagious, but at the same time also to be less lethal. So one can wonder, why has this been developed? And that brings us to another publication, which is about 5 years ago, where the original development of this was done in North Carolina, and where also one of the researchers there was the head virologist at the virology lab in Wuhan. And where also documentation says that the continuous research would happen in Wuhan, and the whole project, even in North Carolina, was paid for by the Chinese. So what we know is that all the further development now of that virus happened at the virology lab in Wuhan, and this was published even 5 years ago, and now it was released, and of course it was an accident. You know, there are all these conspiracy theories about how someone did this to, like one theory is they did it to mask the 5G damage. I will get back to that. But the point is, it was released from that lab, and of course it was an accident. At least I will give people the benefit of the doubt to believe that, and we haven't really seen a good motivation for why this should have been done purposely. And also, when you look at another specific thing about this virus, the way it's engineered, is that it's contagious before you're sick, and that is what makes it also so contagious. And also those 4 spike glycoproteins, it makes it stick better to the cells. So for this to enter the cells, first it needs to stick, and then it needs to go in, and then it needs to do its thing. And that's what it is engineered to do, to be more contagious. There's a 2-meter distance that this can be contagious, even from someone who is not sick with any symptoms. And that's why we cannot really avoid this. You know, we will get this problem. Of course we will. There's no way of stopping it. What we need to do is to make sure that we can handle this as well as we can handle a seasonal flu, which we should totally be able to do. So let's talk a little bit more about self-healing, self-regulated mechanisms, and maybe also taking it a little bit away just from the virus before we